A graphics card is not just a box that creates more frames per second. It is a specialized computer designed to perform thousands of similar calculations at the same time. Understanding that job makes GPU specifications much easier to read. The CPU prepares the game world. It handles logic, player input, artificial intelligence, physics instructions, and draw calls. The GPU receives scene data and turns it into the image on your display. For every frame, it transforms three-dimensional geometry, determines which triangles are visible, converts them into screen pixels, calculates materials and lighting, applies effects, and writes the final image. That parallel workload is why graphics processors contain many smaller execution units. NVIDIA describes CUDA cores, AMD groups work into compute units, and Intel uses SE cores. Those names are not directly interchangeable. A larger number from one architecture cannot be compared one-for-one with a number from another brand or generation. Architecture, clock behavior, scheduling, cache, memory, drivers, and the game all matter. Video memory, or VRAM, stores textures, geometry, frame buffers, shaders, and temporary rendering data close to the GPU. Capacity answers, how much can fit. Bandwidth answers, how quickly can it move. A card can have plenty of memory and still be slower overall. It can also have a fast graphics chip that runs into capacity limits at an extreme texture setting. This is why VRAM is important but never the complete performance score. Traditional rasterization projects triangles onto the screen and shades the resulting pixels. Ray tracing adds calculations that follow light interactions for reflections, shadows, and global illumination. Dedicated ray hardware can accelerate parts of that work, but it still costs performance. AI-focused hardware can accelerate image reconstruction, denoising, and other neural workloads. Upscaling technologies render fewer internal pixels and reconstruct the final output, creating more performance headroom when the implementation is good. A graphics card also contains display engines and media blocks. Those handle monitor outputs and can accelerate video encoding or decoding for streaming, editing, and playback. That means the best GPU for a creator may not be the same as the best value for a person who only plays one competitive game. When choosing a card, begin with the workload. Write down the games or applications, resolution, refresh rate, graphics target, ray tracing interest, and whether you stream or edit. Then check independent testing at those settings. Confirm power supply capacity and connectors, card length and thickness, case airflow, display outputs, and driver support. Do not buy by brand loyalty, VRAM alone, core count alone, or one advertised framerate number. Buy the complete graphics card that fits the complete computer. The GPU builds the picture, but the processor, memory, storage, power supply, cooling, display, software, and game engine determine the experience around it.